Okay. Morning, folks. This is the Network Security Monitoring Validation session. My name is Scott Pack. So several times through this, I'm going to reference an acronym which is completely made up called RISO, which is Rock Your Socks Off. So the goal behind this project that I'm going to be talking about is basically to do everything you can to increase the amount of data that you're sending to your security operations center, to completely inundate them with every piece of information they would ever want. So when I use RISO, that's just talking about this platform that I've created. So a little bit of background about myself. My name is Scott Pack. My alias is PortalUser. You'll have to scroll down a long ways on the Hacker Challenge to find that. I'm a bit of a Pinewood Derby mechanic. I enjoy over-engineering Pinewood Derby cars with jet engines and brushless motors and Arduinos and whatever I can stick in it. I'm a security engineer at Adobe, which lets me work on a lot of fun projects at scale, which kind of leads into the next one. Since we work on a lot of things at a very large scale, I try to automate as much as I can, partially because I like automating stuff and partially because I'm just very lazy. So a little bit of a disclaimer about the data that we're going to be seeing here. It was all generated in the lab or is fake data, so it's not actually indicative of our environment. And I came out of an academia environment, so I did some research with BYU. And if you're in academia and you have something that you want to talk about, but you don't actually want to give people code for it or show them how you did it, you call it a framework. So this is kind of a chunk of the details have been stripped out, but if you're interested about how it was implemented a little bit more behind the scenes, or if you want to get some code to get yourself started on this, come talk to me afterwards and I can help you get started. So a little bit of context around this network security monitoring. So in your investigations or when you're trying to find badness that attackers are doing, you're going to want as much data as you can, because you never know what kind of data is going to be security relevant in an investigation. Prior to Heartbleed, most people were probably not thinking, oh, I should probably be capturing all of my SSL negotiation, renegotiation, and heartbeat packets. Like, that's just not it's not something anyone was doing. So you want to suck in as much as you can. And host information is great. I'm a huge fan of host, like OS logs, application logs. They're invaluable, and I think pretty much any kind of security investigation, if you're lacking those, you're half blind. But network security monitoring comes in really useful because it cannot lie. It can be obfuscated, it can be encrypted, but if an attacker is doing something on hosts in your network, it has to go through your internet connection, which is something that's in your control, and you can put security monitoring controls in line with that or on the side of it to try and catch that badness on its way in or data exfiltration on its way out. So there's several different tiers of network security monitoring. Kind of the weakest one is firewall logs. This source IP tried hitting this port and it was blocked, or it tried hitting this port and it was allowed. And that's not going to give you a whole lot. It'll help you find things like port scans, but if you want to get an idea of what they were actually doing or if it was successful, that's not going to get you very far. The next step is going to be netflows. If you're familiar with Argus, it's what that generates. It's basically a record of a network session that happened. This endpoint talked to this endpoint. It lasted about this long. It was about this big. It happened over these ports. It's good stuff, but it's not going to tell you exactly what they did. It'll tell you what they hit and what protocols they were speaking, but you're not going to be able to see what the attack looked like most of the time. So the next step, which most people think of when they think of network security monitoring, is your intrusion detection system or your intrusion prevention system. It's all right. The problem with most IDS and IPS is that they don't give you all the context around what's going on. So they might trigger on some offending packet and they'll grab that packet and store it for you, but most IDS and IPSs aren't going to capture also the response to that, or they're not going to capture what happened before that or after that. So you might be able to see something that triggered the signature, but you might not be able to see the result of what happened there. Kind of the next step up is transaction monitoring. This is kind of there's a couple tools that'll do this. Bro is a pretty common one, a pretty cool one. basically extracts protocol data from each conversation. So instead of with netflow saying, oh, there was an SSL conversation that happened here, network transaction monitoring will be able to pull out, oh, this is the certificate that was presented, and give you a little bit more information around what happened on the line. Also, it's very, very large. So with transaction monitoring, you're not usually just looking for signatures. You're pulling everything that happens, which means that every network communication that happens is going to result in several lines in a log somewhere, which are really useful and good to have, but they'll take up a lot of disk space. And then if you're willing to put down the GDP of Germany, you can buy a full packet capture solution, drop it in place, and store your data for like 3 days. It's expensive, but it's hard to beat that level of detail. Yeah, so we'll jump on there. Oh, okay. So if you look at your network security monitoring 101, you're going to see a diagram that looks a lot like this. It's like, okay, you have your internet point over here, you have your couple of desktops or your server over here, you just stick an IDS in the middle, and then you're good. Well, does anybody have a network that actually looks like that? Is anyone responsible for a network that has one desktop, one server, one laptop connected to a switch? At home. I'd be surprised most people in here even have a setup at home that is this simple. I think most of us are trying to work with networks that look more like the Tokyo subway system. You have you've got like remote offices, branch offices. You might have some like business partners or subsidiaries. You might have people that have done like cloud bursting and are on Amazon, or you might have network connectivity all over the place. It's hard to keep track of where traffic is coming in, how it's getting around, where it's going out. And I have a massive amount of respect for network engineers and architects that get this set up and actually running. But when it comes down to it, and the business is pushing on them to expand capacity here or there, or to take care of some kind of break-fix outage that's causing an availability problem, kind of the last thing on their mind is when they set up the new thing to make it work, is to tell security, hey, we changed this thing, you'll need to move your taps and your spans around to make sure that you're still seeing your traffic. Like, that's not the top on their priority. Their priority is make it work, and then we'll let security figure it out later. So beyond the network complexity, there's also a bunch of other things that could cause you to be blind to some of your traffic. You'll have your IDS, and it'll be looking at your traffic, usually through a tap or a span or inline, that might be sending this traffic to a traffic aggregator, like a Gigamon or an AppCon or something else. And then that in turn is configured to feed that off to one or more of these different monitoring controls. Well, if there's anything wrong with the tap or span or the network configuration, you're not going to see it. If there's anything wrong with the AppCon or the Gigamon configuration, you're not going to see it. If your IDS or your NSM is oversubscribed, it could be dropping traffic on the interface. If there's some issue with forwarding those events to your alert aggregation or your SIM kind of product, you're not going to be seeing those events. So there's all kinds of places where this information chain can start to break down. So there's kind of two approaches to figuring out if you're seeing everything you want to be seeing. If you're from a QA background or having QA experience, there's a number of different kinds of tests that you can run on software. There's like your smoke testing, your unit testing. Unit testing is awesome because it's very, very specific. You can look for very well honed in on things, pieces of functionality. But the problem here is that there are so many different pieces of functionality in that chain that it's hard to predict everything that could go wrong. Beyond that, it's going to involve a lot of different people. You're going to need people from your network engineering team, your data center operations team, your system administration team, your security engineering team, all of these different groups to check their little component of this process and make sure that it's working. So as I said before, I'm lazy. And I don't want to write all of these individual little tests to look at every minute little component of the pipeline. Instead of pulling up the car and looking under it and checking the alternator and the transmission and everything inside of this car, I'm just going to turn the key. I'm going to do something that should have an expected output, just one that tests the entire thing and see if it comes out right. So there's one way that you could do that is just to send like normal malicious traffic in and out of your network and then see if your security operations team freaks out about it. Well, it's not very nice to your security operations team. They're already digging through tons of false positives as it is. Do we have any security operations people in here? Like do we have people looking at network security monitoring events? We got a couple hands. So I think you're probably feeling the pain of false positives. I think pretty much any organization looks at more false positives than true positives. So I didn't want to cause any more work for them than I had to. So instead of abusing an existing signature in these NSM stacks, I wrote or worked with other people to write a handful of signatures that were just looking for something benign. In this one, it's just looking for HTTP traffic containing the string in it somewhere SaintCon Riso. So it's a good idea to make that a lot more random. I usually use like a 32 character random string, usually a hash sum of some file that I have on my desktop. But as long as that stays the same across all of your requests, and every request, every synthetic transaction, meaning every like fake attack that you're sending in has that, then you would expect that your NSM control would catch it and fire an alert. So beyond that, you have another identifier in each request. You'll see beyond the Riso ID equals SaintCon, you'll see this token equals. So that token needs to be randomly generated for each request that you send across through the IDS. And that'll come into play a little bit more later. It helps you uniquely identify these. All right, so I chose HTTP here kind of arbitrarily, mostly because most NSM controls are pretty flexible and letting you create signatures for HTTP. But really, you could write it for any protocol. I'd like to branch out and start testing additional protocols because HTTP is, it's a good point of view and it's probably the main use case for most of these situations, but it'd be good to get a little bit more breadth there. So this is a suricata or a snort rule. I think we have like 5 or 6 different signatures for different NSM controls. But they pretty much all will have some way of saying, hey, if it's this protocol and contains this string, fire an alert. The nice thing about this is you don't care what's in the middle. You have some host on the inside of your network and some host on the outside of your network, and you're just firing that across, and you're going to see if one of your NSM controls picks it up anywhere. So it's very ignorant of what your network looks like. It's just send it out. Okay, so this is an example of what an IDS alert will look like. This is in JSON format, so it has the alert action allowed, so it permitted the flow, the signature, Riso alert, the category, and then the printable payload. And it's important here to get the printable payload out. So if you're running a SIM like ArcSight or Splunk or whatever, you are pulling these all together, and this is what your security operations folks, your analysts, are looking at. So great, we sent out a request, and we got an alert, we combined them together, and we know that at least this one place that we tested is looking good. Well, that's not really enough, because we have lots and lots of different network segments, lots of locations, lots of boundaries that we want to test. So we needed to find a good way of distributing these requests across the entire environment. Do we have any Salt users, Saltstack folks in the room? No Saltstack. Okay, so Saltstack is a configuration management tool. It's written in Python. It's kind of built and maintained by a group down in Lehigh, Saltstack. It's pretty similar to Ansible or most of your configuration management types of tools. Cool things about it is it's very extensible, and you can write execution modules for it. Meaning I can write a chunk of Python and put it on the Salt master. It will distribute it to all the hosts that it's responsible for controlling, and then I can call that execution module at will to make them do whatever I want. So this is the little active bit of a Salt execution module. You'll see it's taking the IP address, a target IP, the service, in this case HTTP, and then the Riso ID, which would be that SaintCon Riso string. It generates a token, And then it just opens that up and returns the response code. And that's pretty much all that a box needs to do in order to run this test. And then you set it up as a cron tab, or however you want to schedule it on your boxes to make sure that this fires every hour, 20 minutes, 4 hours, whatever period you want to do your testing on. So here I have it running 20 requests. I think for here it's like every half hour or so. I don't have the cron schedule on it. To every minion that's a member of this cluster. So these minions span multiple network segments and should traverse as many boundaries as you can. So if you have some kind of administration network in all of your different sites, that would be a good candidate to run these tests from. So the logs that it creates, the RISO side, that Saltrunner, generates the time it was run, the target, the IP, the response code, the token, and the host that sent out the request. The IDS on the other side collects which host caught it, so you'll be like IDS1 dot wherever dot your domain, and it'll also pull out the printable payload containing the triggering string, here St. Con RISO, and the RISO request token, that random identifier. So the next part here, you'll probably already guess, is you join it all together. So you need to take the inputs from your RISO log, take that, combine it with the results of your IDS event, and stick them together to see what you found and what you didn't. You could probably write a database to do this. I just used what we already had. I used Splunk for this, which resulted in a pretty ugly query. You'll see that like 6-7 lines of Splunk query language at the bottom, but it works pretty well, and it's very portable to other NSM controls. So if you write a signature for another NSM control, you just change like 3 words, 3 little pieces of this, and then you can monitor that entire control as well. So it makes it pretty easy to switch from one control to another. But it does have the dependency of using Splunk as your SIM. Yeah, so if you're lucky, you'll run this report and you'll come out with something that looks like this. Like the lowest rate here, 94%. Most of the sites are at 100%. Like that's pretty dang good. I'll take it. Most folks, I don't think, would have too much of a problem with sampling at 94% in a couple of their locations. Like sure, you could put some work into that to try and bring it up to 100%, but knowing that you're catching 94, 95 is pretty reassuring. Okay, another thing that's interesting here is that usually if you have anything coming out of a site, it's a pretty good bet that your network is set up right. It's probably just a problem with some interface being oversubscribed. So that already will start pointing you in a direction of what problems you might be running into. So it's also possible that you're going to have something that looks more like this, that everything is broken, you can't see crap, but on the upside, no bash O this year. So some zeros, meaning there's some more substantial setup, something is wrong, you're not getting the traffic at all in some sites, some lower percentage capturing, which could be any number of things. So if you start running this and you run into this kind of problem, you end up having to go back and do that whole check every piece of the chain approach. You're bringing in your network engineers and you're bringing in your data center operations to see if somebody's been unplugging things in your data center or somebody's been changing lines around, what's been going on. So it doesn't solve all your problems and it doesn't tell you exactly what the problem is, but it will give you a good idea to where to start looking. So if you're archiving these for any amount of time, you can also answer questions like, during an investigation of 7 days ago, were we even capturing traffic on that site? Or were we even looking at that kind of data? Like it'll help you know how, with what amount of confidence you can say that something did not happen. Which is a scary question. Like it's hard to say, it's scary to ask, all right, if this happened, would I have even seen it? But it's still probably something that you should be asking yourself in your organization. So that's mostly going to wrap it up. There's some things that I'd still like to do with this. There's tracking ingestion delay, so the amount of time that elapses between a bad request coming in or out and when that actually would appear in front of an analyst, I think would be interesting information to look at. There's some hiccups with ingress validation, specifically around anything that proxies requests that could modify or drop your synthetic transactions before they get to where your NSM controls would pick them up. As I said before, I'd like to branch out and start testing things other than HTTP and HTTPS. I think most of the time, just checking HTTP would probably be sufficient. Like, if it hits your IDS and your IDS is looking at it, it's probably going to catch other protocols as well. But for the sake of being complete, I'd like to branch that out more. Also, right now there's a ton of special dependencies. Like, you have to be using, like I mentioned Salt, I mentioned Splunk, I mentioned a couple other things, and right now it's very specific to running that stack of technologies. I'd like to find a way of making it a little more portable and a little bit more technology agnostic, which kind of goes into the next one, additional NSM control support. So as I said, right now I'm supporting like 5 or 6 different NSM controls, and it's not a ton of work to add additional NSM controls, but getting more breadth would make it so that more people could use it. So again, the goal is to get all of these indicators that you may not be seeing and send them to your security operations team, and kind of like not make them drown in false positives, but give them the assurance that they're seeing all the data and all the traffic that they want to anticipate, so that when they say, no, this has not happened, you have a pretty good amount of assurity that that actually has not happened. So any questions I can answer about the system, about what the goals are, about what controls went into it. Any questions I can answer? Nope. Okay. So as a side note, we are looking at Adobe. We are looking for a position on our security operations team. So if you like digging into lots of cool data, using cool tools, and working with cool people, come talk to me afterwards. And yeah, thank you.
How I've been able to use Neo4j